This training includes on-screen sign language interpreting and captioning. Audio description is incorporated into the manner in which the training is presented.
This is Module 3 of the Public Right-of-Way Accessibility Guidelines training. In this module, we will cover the technical requirements in Chapter 3. Chapter 3 includes technical requirements for the following: pedestrian access routes, alternate pedestrian access routes, curb ramps and blended transitions, detectable warning surfaces, crosswalks, pedestrian push buttons and passive pedestrian detection, accessible pedestrian signal walk indications, transit stops and transit shelters, on-street parking spaces, and passenger loading zones. Provision R302 was mentioned several times in Chapter 2 training module. This provision addresses pedestrian access route specifications. And so it goes into the required continuous clear width, passing spaces, grade, cross slope, and surface requirements. The minimum continuous clear width of a pedestrian access route is 48 inches, exclusive of the width of any curb. As pictured in this diagram, you can see it's labeled at least 4 feet of that sidewalk needs to be accessible. Within medians and pedestrian refuge islands, the minimum clear width of a pedestrian access route is 60 inches. There is an exception where you have shared use paths. So where shared use paths cross medians and pedestrian refuge islands, the clear width must be 60 inches minimum, or at least as wide as the crosswalk, whichever is greater. On shared use paths, the clear width of the pedestrian access route must extend the full width for pedestrian circulation on the path. Where bollards are used on the shared use path, for example, to restrict non-authorized motorized vehicles from getting on the path, the bollards cannot reduce the clear width to less than 4 feet, and that's measured from the edge of the bollards. Where the clear width of a pedestrian access route is less than 60 inches, passing spaces must be provided at intervals of 200 feet maximum. The passing spaces must be 60 inches by 60 inches minimum. Those passing spaces and the pedestrian access route are permitted to overlap. On the slide, you can see a 60 by 60 passing space dimensioned and illustrated, and you can see sidewalk where a passing space is provided. The maximum permitted grade of a pedestrian access route located within the highway right-of-way is 5%. Where the grade of the adjacent established roadway exceeds 5%, the pedestrian access route is permitted to match the grade established for the adjacent street. So on the slide, we're showing an urban street that is pretty steep, probably over 5%. And so the sidewalk that's adjacent and within the right-of-way of that street is also permitted to exceed 5%, matching the grade of that existing roadway. For pedestrian access routes not within highway right-of-way, such as the shared use path pictured on the slide, the maximum permitted grade is 5%. Within a crosswalk, the maximum grade of a pedestrian access route is 5%, except where the roadway design requires super elevation greater than 5% at the location of a crosswalk. In that case, the grade of the pedestrian access route within the crosswalk may be the same as the super elevation. The maximum cross slope of a pedestrian access route not contained within a crosswalk is 2.1%. For example, the sidewalk in this picture is sidewalk that's not within a crosswalk. And so the maximum allowable cross slope is 2.1%. There is an exception to that 2.1% cross slope requirement for pedestrian access routes not contained within a crosswalk. This exception applies to the pedestrian access route in the roadway. So as pictured, the route that a driver parked in an on-street parallel parking space that's not directly connected to the sidewalk, the path they take to get from the driver's side of the car to the nearest curb ramp. And the exception reads, the portion of a pedestrian access route within a street that connects an accessible parallel on-street parking space to the nearest crosswalk at the end of the block face or the nearest mid-block crossing is not required to have a maximum cross slope of 2.1%. The cross slope of pedestrian access routes contained within a crosswalk depends on the location of the crosswalk. And I will refer to these requirements multiple times when discussing the cross slope requirements at curb ramps and blended transitions. So at a crosswalk with yield or stop control devices, the maximum allowed cross slope is 2.1%. At an uncontrolled approach, the maximum allowed cross slope is 5%. At a crosswalk with traffic control signal or pedestrian hybrid beacon, the cross slope can be up to 5%. And lastly, for crosswalks located at mid-block or roundabouts, the cross slope should be no greater than the grade of the road. Surfaces are addressed in R302.6. The requirement is that the walking surfaces of pedestrian access routes, elements, and spaces that are required to be accessible must be stable, firm, and slip resistant. This is an illustration from our guides that shows a surface that meets these requirements. Grade breaks on a pedestrian access route must be flush. In the Chapter 1 training module, I mentioned that the vertical surface discontinuity terminology has been replaced with changes in level, which is consistent with both the ADA and the ABA accessibility guidelines. Changes in level are permitted to be up to 1/4 inch without treatment, or 1/2 inch if beveled with a slope no steeper than 1:2. Where you have changes in level that are greater than 1/2 inch up to 6 inches, you must have a slope no greater than 8.3%. Changes in level that are greater than 6 inches must be treated as a ramp and comply with ramp requirements in R407. Horizontal openings in ground surfaces should not allow the passage of a sphere larger than 1/2 inch in diameter. There are exceptions at flangeway gaps, which we will cover in a couple of slides. Elongated openings should be placed such that the long dimension is perpendicular to the dominant direction of travel, as illustrated in this slide. Where multiple directions of travel intersect, elongated openings should be placed perpendicular to the dominant direction of travel. Where a pedestrian access route crosses rails at grade, the pedestrian access route surface must be level and flush with the top of the rail at the outer edges of the rails, and the surface between the rails must be aligned with the top of the rail. You can see in this picture on the slide that the pedestrian access route surface is aligned with the top of the rails. Flangeway gaps at tracks subject to FRA safety regulations are allowed to be up to 3 inches wide. Flangeway gaps at tracks not subject to FRA safety regulations are allowed to be up to 2.5 inches wide. The requirements for flangeway gaps have been set at the narrowest dimension that allows trains to safely traverse a pedestrian crossing. And in the image, it's labeled where a flangeway gap is located. And in this case, as you can see, it's significantly bigger than what we would require for the horizontal openings. The proposed rule did not include technical provisions for alternate pedestrian access routes. Rather, the scoping incorporated the specific provisions of the MUTCD. In provision R303 of the final rule, the board has specified the required accessibility features of alternate pedestrian access routes to ensure that they are detectable and contain the basic accessibility features of the closed route without being overly burdensome. Provision R303 addresses the following features of alternate pedestrian access routes. It addresses signs, surface, the continuous clear width, curb ramps or blended transitions, detectable edging of channelizing devices, as well as pedestrian signal heads. Signs identifying alternate pedestrian access routes must be provided in advance of decision points and must comply with R410. Proximity actuated audible signs or other non-visual means within the public right-of-way of conveying the information that identifies alternate pedestrian access routes must also be provided. The signs are intended to provide clarity to pedestrians with low vision or who are blind, information as to where the alternate pedestrian access route is located. Placing those signs ahead of decision points, such as at an intersection that precedes a closed sidewalk, reduces the need for pedestrians to retrace their steps or attempt to cross a roadway at a place other than a crosswalk. The surface of an alternate pedestrian access route must comply with technical accessibility requirements for surfaces at R302.6, at least to the extent that the closed route complied with those surface requirements. This is consistent with the proposed rules reference to MUTCD, which requires that temporary pedestrian facilities have accessibility features consistent with the closed route. So remember, R302.6 addressed requirements for a firm, stable, and slip-resistant surface with flush grade breaks and changes in levels beveled or sloped when they exceeded 1/4 inch. R302.6 also addressed limitations on horizontal openings and surfaces at grade rail crossings. The minimum continuous clear width of an alternate pedestrian access route is 48 inches, unless it qualifies for the exception, which states where the alternate pedestrian access route utilizes an existing pedestrian circulation path. The width must be no less than the width of the temporarily closed pedestrian circulation path. So what that means, for example, if you have 3-foot sidewalk on both sides of the road and need to close off one side, you can detour pedestrians to the 3-foot sidewalk on the other side of the road. Curb ramps or blended transitions that are on alternate pedestrian access route, they need to be provided if the alternate pedestrian access route crosses a curb ramp, or a blended transition should comply with R304 if it's provided at an alternate pedestrian access route. Where a channelizing device is used to delineate an alternate pedestrian access route, continuous detectable edging must be provided throughout the entire length of the route. The only exception is obviously where pedestrians or vehicles turn or cross, or in those locations, gaps in the detectable edging is permitted. The top of the detectable edging must be no lower than 32 inches above the walking surface, It must be free of sharp or abrasive surfaces. And the bottom of the bottom detectable edging must be 2 inches maximum above the walking surface. Where temporary pedestrian signal heads are provided at a crosswalk that is part of an alternate pedestrian access route, pedestrian push buttons or passive detection devices must be provided and comply with R307. R307 provides technical requirements for pedestrian push buttons and passive pedestrian detection, and we will discuss those later in this module. Provision R304 addresses technical requirements for curb ramps and blended transitions. It includes requirements for perpendicular curb ramps, parallel curb ramps, blended transitions, and also addresses the common requirements for these 3 features. We'll start with perpendicular curb ramp requirements. The running slope of a perpendicular curb ramp is perpendicular to the curb or gutter as pictured on the slide. The maximum allowed running slope for a perpendicular curb ramp is 8.3%. There is an exception to the 8.3% running slope requirement, and this exception has been commonly referred to as the 15-foot rule. It basically states that where the curb ramp length must exceed 15 feet to achieve an 8.3% running slope, the curb ramp length must extend at least 15 feet and may have a running slope greater than 8.3%. The maximum allowed cross slope for a perpendicular curb ramp is 2.1%. The exception to this 2.1% cross slope is tied to the crosswalk. If you recall in R302.5, we allow that at uncontrolled crosswalks, the cross slope can be up to 5%, where you have crosswalks at a traffic control signal or pedestrian hybrid beacon crosswalk, the cross slope can be up to 5%. And for mid-block and roundabout crosswalks, the cross slope can be up to the grade of the street. So it follows that the curb ramps adjoining those crosswalks would be allowed the same cross slope. So that exception reads, at crosswalks, the cross slope of the curb ramp run is permitted to equal to or less than the cross slope of the crosswalk as specified by R302.5. Grade brakes at the top and bottom of a curb ramp must run perpendicular to the direction of the curb ramp run, and the grade brakes are not permitted on the surfaces of curb ramp runs and landings. The surface slopes must meet at surface slopes that meet at grade brakes must be flush. A 48-inch by 48-inch clear area is required beyond the bottom grade brake of a perpendicular curb ramp. If the perpendicular curb ramp is at a shared use path, the clear area must be as wide as the shared use path. The clear area must be located within the width of the crosswalk and outside the vehicle lanes, including bike lanes that run parallel to the crosswalk. The maximum allowed running slope for the clear area is 5%. The clear area cross slope required is tied to R302.5 because the clear area is essentially part of the crosswalk. And again, remember R302.5 gives the requirements for the cross slope within a crosswalk. Where there's the option to change direction of travel at the top of a perpendicular curb ramp, as pictured on the slide, a landing is required. The landing must be 48 inches by 48 inches unless it's at a shared use path, where that landing must be as wide as the shared use path. Where a landing serves only one curb ramp, as pictured on the slide, the landing slope measured perpendicular to the curb ramp run must be equal to or less than the cross slope of the curb ramp run, and the landing slope measured to the curb ramp run cannot exceed 2.1%. Where a landing serves two curb ramps, the landing slope in either direction of travel cannot exceed the cross slope of the crosswalk parallel to the direction of travel as specified in R302.5. Where the pedestrian circulation path crosses the side of a perpendicular curb ramp as pictured on the slide, the side of the curb ramp must be flared. The slope of the flare cannot exceed 10%. Perpendicular curb ramps or their landings must be connected to adjacent pedestrian facilities by pedestrian access routes. So when you construct a new curb ramp or alter an existing curb ramp, the expectation is that it be connected to adjacent pedestrian facilities. A transitional segment as defined in Chapter 1 can be used to make that connection. The running slope of parallel curb ramps must be parallel to the curb and cannot exceed 8.3%. Similar to perpendicular curb ramps, the 15-foot rule applies. And the exception is that where the curb ramp run length must exceed 15 feet to achieve 8.3% running slope, the curb ramp run length must extend at least 15 feet and may have a slope greater than 8.3%. The maximum cross slope allowed for parallel curb ramps is 2.1%. Grade breaks at the top and bottom of the curb ramp run must be perpendicular to the direction of the curb ramp run. Grade breaks are not permitted on the surface of curb ramp runs or landings. Surface slopes that meet at grade breaks must be flush. Landings must be provided at the bottom of parallel curb ramps. Landings must be 48 inches wide minimum by 48 inches long minimum. The slope of the landing measured parallel to the direction of travel on the curb ramp run is permitted to equal to or less than the slope of the roadway or the cross slope of the crosswalk as specified by R302.5. Remember, we talked about those cross slope requirements at a crosswalk. And again, in this case, for a parallel curb ramp, the landing is permitted to have cross slope similar to the attached crosswalk. The cross slope of the landing cannot exceed 2.1% measured perpendicular to the direction of travel on the curb ramp run. Lastly, we have blended transitions. Blended transitions are allowed a maximum running slope of 5% as pictured. Just like parallel and perpendicular curb ramps, the cross slope of blended transitions is tied to the cross slope of the adjoining crosswalk as specified in R302.5. And that cross slope requirement is the cross slope of blended transitions must be equal to or less than the cross slope of the crosswalk as specified by R302.5. The bypass requirement was implied in the proposed rule and more explicitly stated in the final rule. And it's also illustrated on this slide in red. That is the bypass that is in red. So where a blended transition serving more than one pedestrian circulation path has a running slope greater than 2.1%, a pedestrian access route must be provided so that a pedestrian who's not crossing the street may bypass the blended transition. We'll now cover common requirements for curb ramps and blended transitions, and those include width. The width of curb ramp runs, excluding flared sides, and blended transitions must comply with the following as applicable. Curb ramps and blended transitions not on shared use paths must be at least 48 inches wide. Curb ramps and blended transitions on shared use paths or attached to shared use paths must be equal to the width of the shared use path. So that's the width of the curb ramp runs, excluding flares, or the width of the blended transition. Another common requirement is the change of grade. The change of grade requirement is more clearly articulated in the final rule, and it's illustrated on this slide and the next slide. So basically, the sum of the requirement is that at gutters and streets where a change of grade occurs adjacent to curb ramps and blended transitions, the change of grade must comply with either options A, which I'll talk about on this slide, or option B, which I'll talk about on the next slide. And basically for option A, the sum of the grade of the crosswalk, so you're looking at the grade of your crosswalk, and the grade of the adjacent curb ramp or blended transition cannot exceed 13.3%. Option B, if the sum of the grade of the crosswalk plus the grade of the adjacent curb ramp or blended transition exceeds 13.3%, a transitional space at least 2 feet in the direction of pedestrian travel, and for the full width of the curb ramp run or blended transition must be provided at the bottom of the running slope of the curb ramp run or blended transition as pictured. So on the slide, you can see the curb ramp comes down 8.3%, and because the cross slope is at 5% or greater, you need to have this transition space that needs to be at least extend at least 24 inches in the direction of travel. The last common requirement is the width at the crosswalk. Perpendicular curb ramp runs, parallel curb ramp landings, and 48 inches minimum width of a blended transition must be contained wholly within the width of the crosswalks they serve. At shared use paths, however, the full width of a perpendicular curb ramp run, parallel curb ramp landing, or the blended transition must be contained wholly within the width of the crosswalk it serves. Provision R305 covers detectable warning surfaces. Detectable warning surfaces must consist of truncated domes in a square or radial grid pattern and comply with R305. R305 speaks specifically to dome size, dome spacing, the contrast of detectable warning surface to the adjacent surfaces, as well as the detectable warning surface panel size. The dome size is pictured on the slide, and it must have a base diameter of 0.9 inches minimum and 1.4 inches max. The top diameter of 50% of the base diameter minimum and 65% of the base diameter maximum. The height of the dome is 0.2 inches. When detectable warning surface tiles are cut to fit, partial domes are permitted along the cut edges. Dome spacing is also pictured on the slide, and it must have a center-to-center spacing of 1 to 6 inches minimum to 2.4 inches maximum, and a base-to-base spacing of 0.65 inches minimum, measured between the most adjacent domes. When detectable warning surfaces are cut to fit, center-to-center spacing measured between domes adjacent to cut edges cannot exceed twice the normal spacing between domes not adjacent to cut edges. Dome spacing requirements do not apply at gaps in detectable warning surfaces that are located at expansion joints, provided that the detectable warning surface aligns on both edges of the expansion joint. Detectable warning surfaces must contrast visually with the adjacent walking surfaces, either light on dark or dark on light. And then example of that is illustrated on the slide. Detectable warning surfaces must extend at least 2 feet in the direction of pedestrian travel. The width of detectable warning surfaces is dependent on where they are placed. So on curb ramps and blended transitions, detectable warning surfaces must extend for the full width of the curb ramp run, excluding flared sides, or the full width of the blended transition, or at a parallel curb ramp, the full width of the landing. At cut-through pedestrian refuge islands, detectable warning surfaces must extend the full width of the pedestrian circulation path opening. At pedestrian at-grade rail crossings not located within a street, detectable warning surfaces must extend the full width of the pedestrian circulation path opening. At boarding platforms, they must extend the full length of unprotected areas of the platform. At rail vehicle boarding and alighting areas at sidewalk or street level transit stops, they must extend the full length of the unprotected area of the transit stop. Where a concrete border is required for proper installation, of a detectable warning surface, a concrete border not exceeding 2 inches is permitted on all sides of the detectable warning surface. This language was previously in an advisory. It has now been incorporated in sub-provision R305.2. Between the detectable warning surface and the edge of pavement where a setback is already permitted, the 2 inches is included in that setback. This is particularly for perpendicular curb ramps where a setback is permitted based on the location of the grade break. On perpendicular curb ramps where the ends of the bottom grade break are in front of the back of curb or at the edge of pavement where there is no curb, the detectable warning surface must be placed at the back of curb or no greater than 6 inches from the edge of pavement where there is no curb, so that 2 inches allowed for the proper installation of detectable warning surface is accounted for in that 6-inch setback. In other words, you don't get 2 inches plus 6 inches for a total of 8 inches. On perpendicular curb ramp runs, as pictured, where the ends of the bottom grade break are behind the back of curb or edge of pavement where there is no curb, and the distance from both ends of the bottom grade break to the back of curb or edge of pavement where there is no curb is less than 60 inches or less, the detectable warning surface must be placed on the ramp run at the bottom grade break. On perpendicular curb ramps where the ends of the bottom grade break are behind the back of curb or edge of pavement where there is no curb, and the distance from either end of the bottom grade break to the back of curb or edge of pavement where there is no curb is more than 60 inches, the detectable warning surface must be placed on the clear area so that both front corners of the detectable warning surface are at the back of curb or no greater than 6 inches from the edge of pavement where there is no curb. On parallel curb ramps, as pictured, detectable warning surfaces must be located on the landing at either the back of curb or the edge of pavement where there is no curb. On blended transitions, detectable warning surfaces must be located on the blended transition so that both front corners of the detectable warning surfaces are at the back of curb or no greater than 6 inches from the edge of pavement where there is no curb. And on the slide, we show what that would look like on a blended transition. At cut-through pedestrian refuge islands, detectable warning surfaces must be located no greater than 6 inches from the edges of the pedestrian refuge island or at back of curb and must be separated by 24 inches minimum length of surface in the direction of travel without detectable warning surface. Remember that in the final rule, pedestrian refuge island is defined as an area 72 inches long minimum in the direction of pedestrian travel, located between traffic lanes for pedestrian refuge within a median, splitter island, or channelizing island. So every refuge island is not necessarily going to meet the definition of pedestrian refuge island as defined in PROAC and require detectable warning surface. The illustration on the slide shows that minimum required 2-foot spacing between the detectable warning surface panels. At pedestrian at-grade rail crossings not located within a street, the edge of the detectable warning surfaces must be located between 6 feet to 15 feet maximum from the center line of the nearest rail. Where pedestrian gates are provided, and we show that in the illustration, detectable warning surfaces must be located on the side of the gate opposite the rail. Pedestrian gates cannot overlap detectable warning surfaces. At boarding platforms for transit vehicles, detectable warning surfaces must be located at the boarding edge of the platform. The only exception is where a curb is present at the boarding edge of the platform. In that case, the detectable warning surface may be placed at the back of curb. And the picture on the slide shows detectable warning surfaces along the length of a bus boarding platform. At boarding and alighting areas at sidewalk or street level transit stops for rail vehicles, detectable warning surfaces must be located at the edge of the boarding and alighting area closest to the rail vehicles. And the picture on the slide shows sidewalk level boarding and alighting with detectable warning surface. The last location where detectable warning surfaces are required is at driveways controlled with yield or stop control devices or traffic signals. Detectable warning surfaces must be provided on the pedestrian circulation path where the pedestrian circulation path meets the driveway. This requirement was previously stated in advisory, and it is now a provision in the final rule. Where driveways are controlled with yield or stop control devices or traffic signals, detectable warning surfaces must be provided. I will now turn it over to Scott Windley for the remainder of this training module.
Okay, we're continuing module 3. We're in Crosswalks, section R306. Section R306 includes 306.2, pedestrian signal phase timing, R306.3, accessible walk indication, R306.4, roundabouts, R306.5, channelized turn lanes. Pedestrian signal phase timing, where a traffic control signal with a pedestrian signal indication is provided at a crosswalk. The pedestrian signal phase timing is based on a pedestrian clearance time that is calculated using a walking speed of 3.5 feet per second. It can be less than that as well, and it is measured from the location of the pedestrian push button to a pedestrian refuge island or the far side of the traveled way if it's a full crossing without a pedestrian refuge island. The walk interval, the total time that the walking man is shown, must be 7 seconds minimum. Where the pedestrian clearance time is calculated to a pedestrian refuge island, an additional pedestrian push button or passive detection device must be provided on the pedestrian refuge island. If a passive pedestrian detection device is used to automatically adjust the pedestrian clearance time based on the pedestrian's actual clearance of the crosswalk, a faster walking speed may be used. What that means is that if you're using passive detection to either extend the walking time for any slower pedestrians, you're allowed to use a quicker crossing time for the situations where you may not have a slower pedestrian. An accessible walk indication complying with, this is where we're talking about accessible walk indications. An accessible walk indication complying with R308.2 must have the same duration as the walk interval. Now, what that means is that the audible signal, the accessible signal has to indicate that audibly the same amount of time as the actual time that the walking man is shown on the display. Where the pedestrian signal rests and walk, the accessible walk indication may be limited to the first 7 seconds of the walk interval. And what that means is that if you have a pedestrian signal that rests and walk, because there's sufficient, because it allows for you to cross the intersection when there are no vehicles, then it's not required to continually give the audible walk indication. But the audible walk indication is required when the button is pressed, and it has to last for at least the first 7 seconds of the walk interval. If the pedestrian signal is resting and walking, there is sufficient time remaining to provide an accessible walk interval before the beginning of the pedestrian change interval. The accessible walk indication may be recalled by a button press. So if we go on, we're going to talk about roundabouts. Roundabouts. First thing we want to talk about is edge detection. Edge detection, where pedestrian circulation paths are provided at roundabouts, edge protection is required on the street side edge of the pedestrian circulation path at the approach and along the circulatory roadway of the roundabout, where crossing is not intended. So basically that means that you have to provide some sort of edge detection, either a landscaping surface or a fencing, if it's a curb attached sidewalk, that prevents all pedestrians from crossing into the circulatory roadway. And that edge detection goes from crosswalk to crosswalk through the sections of the circulatory roadway, which is like what is shown in this image here, where it shows a fence basically protecting the circulatory roadway from or protecting pedestrians from encroaching on the circulatory roadway. Now, edge detection is required where pedestrian circulation path is not attached to the curb, landscaping, or other non-prepared surface. It's 24 inches wide minimum. So if you're not using a fence, the edge protection, it has to be, if you're using landscaping or other type of non-prepared surface, has to be 24 inches wide minimum. If you use a vertical edge treatment, then it has to be continuous and detectable, and the bottom edge must be no more than 15 inches above the pedestrian circulation path, which means that it's cane detectable. Crosswalk treatments and roundabouts. Each multi-lane segment of a roundabout containing a crosswalk must provide a crosswalk treatment consisting of one or more of the following. When we say multi-lane segment, we're talking about where the roundabout has more than one lane going in the same direction. So that's, and the type of crossing treatment that is considered acceptable is either a traffic control signal with a pedestrian signal head, a pedestrian hybrid beacon, a pedestrian actuated rectangular rapid flashing beacon, a raised crossing, or a combination of those things. Like sometimes they may do a raised crossing with a pedestrian actuated rectangular rapid flashing beacon, and that's perfectly fine. They don't have to be, they can be combined in the appropriate ways. Now, in addition to roundabouts, we have crosswalk treatments that are permitted at multi-lane channelized turn lanes. And we'll basically allow the same type of treatment, crossing treatments. They include the traffic control signal with pedestrian signal head, a pedestrian hybrid beacon, a pedestrian actuated rectangular rapid flashing beacon, or a raised crossing, or a combination of those devices. Now, let's talk about pedestrian push buttons and passive pedestrian detection, R307. R307 includes describing how you activate the pedestrian push button. In 307.2, it also talks about R307.3, extended push button press, what needs to be provided when you have an extended push button press requirement or allowance. And then R307.4 deals with the location of the push button. R307.5 deals with push button orientation. R307.6 deals with the audible and vibrotactile walk indications for the pedestrian signal heads. R307.7 is the audible and vibrotactile indications for pedestrian activated warning devices without a walk indication. So R307.7 is a specific thing which we'll discuss that deals with rectangular rapid flashing beacons. R307.8 is locator tone requirement. R307.9 is tactile arrows that are required on the push, somewhere on the push button device. Typically on the actual push button. So if we're going to pedestrian push buttons, operable parts of pedestrian push buttons must comply with R403. R403 is in chapter 4, we talk about reach range requirements and the operable part requirements of being operable with one hand and not requiring tight pinching or twisting of the wrist, which we'll talk more about in module 4. Pedestrian push buttons and passive detection devices must activate the accessible pedestrian signals and, where applicable, the walk interval. If you have an extended push button press provided, if it's being used to provide any additional features, a push button press of less than 1 second must actuate only the pedestrian timing and any associated accessible walk indication, but a push button press of 1 second or more would actuate the options that you might provide, which may be pedestrian timing, any associated accessible walk indication, and any additional features. And the additional features may be additional crossing time can be provided by an extended button press. And when you provide an extended button press features, you need to provide a sign indicating what features are provided by the extended button press, and it must be mounted adjacent to or integral to the pedestrian push button itself. Pedestrian push button location. It's very important of the orientation and the position and location of the pedestrian push button for it to be most easily usable by a person with a vision impairment. Pedestrian or a sensory disability as well, since there's the vibrotactile component of this. Pedestrian push buttons must be located no greater than 5 feet from the side of a curb ramp run or the edge of the furthest associated crosswalk line from the center of the intersection. So in this case, the furthest crosswalk line is the inside crosswalk line going towards going into the street that you're crossing. Pedestrian push buttons must be located between 1.5 and 10 feet from the edge of the curb or pavement. Where two pedestrian push buttons are provided on the same corner, they must be 10 feet or more apart. Now, there is an exception to this because sometimes this is not achievable. A lot of times in alterations, this is not achievable. So in alterations, where technically infeasible to provide 10 feet separation between pedestrian push buttons on the same corner, a pedestrian push button information message complying with R308.3.2 must be provided. And that we will talk about in a minute, but it basically is that it requires a verbal message rather than just the rapid tick. Push button orientation. The face of the push button must be parallel to its associated crosswalk. Audible and vibrotactile indications for pedestrian signal heads. The pedestrian push buttons or passive detection device must activate both the audible and vibrotactile walk indication complying with R308. And then on the device, on the front of the device, a tactile arrow needs to be provided for either the button itself or the device itself has to have a tactile arrow that indicates the direction of travel for the associated crosswalk. And it also has to have high visual contrast. So it's just showing you in this image a raised tactile arrow on the push button itself that indicates the direction. If you push that button, that's the direction that you're crossing. Audible and vibrotactile indication. For pedestrian activated warning devices without a walk indication, okay, this is for where a pedestrian push button or passive detection device is provided for pedestrian activated warning devices, such as RRFBs, which don't have a pedestrian, the walk indication and the don't walk indication, you know, the visual indications of that. The pedestrian push button or passive detection device must activate a speech message that indicates the status of the beacon in lieu of an audible walk indication. So what we don't want to have the RRFB push button say is we would want it to say something like the beacons are currently flashing. We don't want to say the walk sign is on because there is no walk sign. So now where a pedestrian push button is provided, it should not, in this condition of not having a walk indication, when a pedestrian push button is provided, it should not include a vibrotactile feature indicating the walk interval. And the speech message must comply with R308.4, which we'll discuss in a couple slides from now. So if we go on and deal with the locator tone duration, the locator tone, pedestrian push button must incorporate a locator tone. The locator tone's purpose is for it to indicate to a blind pedestrian, blind or low vision pedestrian, that there is a push button to activate this crossing. And the locator tone has a duration requirement. The locator tone has a duration of 0.15 seconds or less, and it must repeat at 1 second intervals, except when another audible indication from the same device is active. When another audible indication from the same device is active, the locator tone must be silenced. So, and what that means is when the walk indication is going off on the device, you don't have the walk indication and the locator tone at the same time. The locator tone comes back on after the walk indication has completed. A locator tone may be silenced if a passive detection system activates the locator tone when a pedestrian is within 12-foot radius of the pedestrian push button. What this does is it makes it so that instead of having to have the locator tone going all the time when there's maybe no pedestrians around at all, if you have a passive detection system that activates the locator tone when a pedestrian is within 12 feet of the pedestrian push button, then the pedestrian, the locator tone can be silenced until the condition where the pedestrian is within the 12-foot radius, and then the locator tone must start back up. So I do want to mention that these provisions that I'm talking about right now with the locator tone and all the things with the push buttons is consistent with the MUTCD requirements that in the proposed rule we had referenced, but now have incorporated these requirements and made them a shall condition in the final rule. Now, the locator tone is able to adjust, it should be able to adjust in response to ambient sound. It's required to be able to do that. Pedestrian push button locator tones must be in intensity responsive to ambient sound, and it must be audible 6 feet to 12 feet from the push button or to the building line, whichever is less. The push button locator tone must be louder than ambient sound up to a maximum volume of 5 dB louder than ambient sound. Automatic volume adjustment in response to ambient traffic sound levels must be a maximum volume of 100 decibels in total. So we don't want anybody to lose their hearing over these locator tones. Locator tone and audible beaconing. Where audible beaconing is used, what's that? What audible beaconing does is it provides some wayfinding cues for pedestrians. It's not necessarily required, but where audible beaconing is used, the volume of the push button locator tone during the pedestrian change interval of the called pedestrian phase must be increased and operated in one of the following ways. And we give you 3 different ways to do it. The louder audible walk indication and louder locator tone comes from the far end of the crosswalk as pedestrians cross the street. And then the louder locator tone comes from both ends of the crosswalk, or the louder locator tone comes from an additional speaker that is aimed at the center of the crosswalk that is mounted on a pedestrian signal head. So those are your options if you're doing audible beaconing. Again, audible beaconing is merely an option and not a requirement. Locator tone and traffic control signal in flashing mode. This is one area where we have departed from the MUTCD requirements. When the traffic control signal is operating in a flashing mode, the pedestrian push button locator tone must remain active, and the pedestrian push button must activate a speech message that communicates the operating mode of the traffic control signal. Where traffic control signals or pedestrian hybrid beacons are activated from a flashing or dark mode to stop and go mode by pedestrian actuation, a speech message communicating the operating status of the traffic control signal is not required. So let me try to explain these 2 situations to you. Is that the flashing mode is where you have, say, the north-south direction is flashing red for the drivers. The signal is flashing red, and the east-west direction is flashing yellow. And when a person who is sighted comes up to the intersection, they can look at the signals and see that the pedestrian signal is been shut down and that they're in this flashing mode situation. Whereas a person who's blind or has a vision impairment doesn't have the ability to just look at the signal and know that. So what this what this does is gives when they push the button, it gives them the information that the pedestrian signals are not functioning, and that the traffic signal or the traffic control device is in a flashing mode. So if you have the ability to override the flashing mode, which is what the second bullet is talking about, is if you have the ability to override that by pushing the button and having it go into a regular system, then you don't have to have the speech message component. But if you don't have that, then you have to have the speech message component that basically tells the blind pedestrian that the signal is in flashing mode. Now, accessible pedestrian signal. This is the audible and vibrotactile walk indications of R308.2, R308.3, audible walk indications. R308.4 deals with the volume. R308.5 deals with vibrotactile walk indication. So let's go through those of R308. First, we're going to talk about the audible and vibrotactile walk indications. Accessible pedestrian signals must have audible and vibrotactile walk indications during the walk interval only. The audible walk indication must be audible from the beginning of the associated crosswalk. Following the audible and vibrotactile walk indication and during the pedestrian change intervals, the accessible pedestrian signal must revert to the pedestrian push button locator tone. So when it's not indicating the walk indication, all it does is give you the locator tone. Now, what is the audible walk indication? What is the requirement? It's not the cuckoo chirp that we the old systems. They got phased out because of they were tended to be imitated by birds. What is now used is what we call a percussive tone, where an accessible pedestrian signal is provided at a single crossing, or where two accessible pedestrian signals are 10 feet or greater from each other at a corner. The audible walk indication must be a percussive tone and repeat 8 to 10 ticks per second with multiple frequencies and a dominant component at 880 hertz. Now, the percussive tone is what you typically want to do. Now, when you have a situation where it is difficult to tell which signal is giving you which signal is running at the time, like if they're close together, less than 10 feet apart, or maybe even on the same pole, what you want to do is a speech walk message. So in alterations where it is technically infeasible to provide 10 feet separation between pedestrian push buttons on the same corner, the audible walk indication for each signal must be a speech walk message that complies with R308.3.2. And that's going to be a speech walk message, which we'll talk about in a minute, instead of the percussive tone. Now, where speech push button information messages are made available at a pre-timed signal or by actuating the accessible pedestrian push button or passive detection device, they must only be actuated when the walk interval is not timing. So they must begin with the term wait, followed by an intersection identification information modeled after the idea of wait to cross broad at Grand. That gives the blind pedestrian the knowledge that they're trying to cross Broadway. If they want to cross Broadway at Grand, this is the button that they want to press. And when they press it, it tells them to wait. If information on intersection signalization or geometry is also given, it must follow the intersection identification information. Now, speech walk messages are very specific. Speech walk messages during pedestrian phase concurrent with the vehicle phasing. Speech walk messages that are used at intersections having pedestrian phasing that is concurrent with the vehicle phasing must be patterned after the model of stating the street, Broadway, walk sign is on to cross Broadway. So you state the street first and then indicate that the walk sign is on. And that's the way the speech message should be recorded. Speech walk message during exclusive pedestrian phasing. If there's a situation where all pedestrians or all vehicles stop when the signal is on, then speech walk message that are used at intersections having exclusive pedestrian phasing must be patterned after the model walk sign is on for all crossings. Speech walk message and pilot light. If a pilot light is used in an accessible pedestrian signal location, each actuation must be accompanied by the speech message, wait. Okay, just because sighted pedestrians can see that the pilot light is on and the message, I mean, the push button has been pressed. But again, a blind pedestrian is going to press that push button because they're not going to necessarily know anybody has pressed it for them. And so whenever that push button is pressed, it needs to indicate wait. Okay. Now, if we go on to the volume, audible walk indications must be louder than the ambient sound up to a maximum volume of 5 dBA, louder, that's decibels, louder than ambient sound. Automatic volume adjustment in response to ambient traffic sound level must be a maximum volume of 100 decibels. Where audible beaconing is provided, this is an exception, where audible beaconing is provided in response to an extended push button press, the beaconing can exceed the 5 decibels louder than the ambient sound. So beaconing tends to be a little louder than the walk indication. The pedestrian push button must vibrate during the walk interval. This is the piece of the requirement that addresses those people that may be both blind and hard of hearing or deaf. And this provides a vibrotactile indication that the walk signal is activated, and basically the device vibrates, as well as the audible indication. Transit stops and transit shelters. We're now into R309. R309 deals with transit stops, both the boarding and the lighting area of transit stops, the boarding platform, and common requirements for a transit stop. Transit shelters, it's not all transit stops have to have a transit shelter. We don't require the shelter. But if a shelter is provided, there are requirements, and they are covered in 309.2.1, connection to boarding and the lighting area. We require a clear space, 309.2.2. 309.2.3 is environmental controls, and 309.2.4 is protruding objects. Okay, so let's go through this. Boarding and the lighting area. A boarding and a lighting area must serve each accessible vehicle entry and exit. So if there's a bus that has 2 of those entrances or exits, then there needs to be 2 boarding and lighting areas. The accessible ones. Dimensions are 96 inches minimum measured perpendicular to the curb by 60 inches minimum measured parallel to the street. The slope perpendicular to the street can be up to 2.1% maximum. That's the standard kind of cross slope, but we refer to it as the slope perpendicular to the street in this condition. The slope parallel to the street, of course, can match the slope of the street. That's consistent with the rest of the standards that we've discussed today. Now, the boarding platform. There has to be a platform and vehicle floor coordination. The boarding platform must be positioned to coordinate with the vehicle in accordance with the applicable requirements in 49 CFR Part 37 and 38. That's DOT's standards for vehicle and platform floor coordination. the slope of the boarding platform, if it is a boarding platform, like on a rail a system or a BRT where you're doing level boarding, this is what we're talking about here, is level boarding. The slope of the boarding platform measured parallel to the track or street must be the same as the grade of the track or street, and the slope of the boarding platform measured perpendicular to the track or street can be up to 2.1%, which is the same as it is for the bus stops, which we talked about in the last slide. Now, the common requirements between these two, either a rail platform or a bus stop or a bus rapid transit platform, these are the common requirements. There must be a connection to existing pedestrian circulation paths. In alterations, boarding and aligning areas and boarding platforms must be connected to existing pedestrian circulation paths by pedestrian access routes complying with R302. So it has to connect. Doesn't necessarily indicate the condition of what you're connecting to, but it needs to connect by means of a pedestrian circulation path. So the surface of the boarding and aligning area and the boarding platform has to comply with 302.6, which is the usual requirements of stable, firm, and slip resistant. Okay, and we've already indicated the slope requirements previously. If you provide a transit shelter, it must be connected by a pedestrian access route to the accessible boarding and aligning area or the boarding platform. An additional requirement that we've added to the rule is where, and this was I think an advisory, or was mentioned in the proposed rule, but wasn't a full-on requirement, is where provided if there are environmental controls within the transit shelter, they must be proximity actuated. So they don't require somebody who has a vision impairment to try to figure out how the controls are operated. If you have environmental controls in your transit shelter, it must be proximity actuated. And there's the protruding objects within a transit shelter must comply with the protruding object requirements, which I'll talk to you about in module 4. Now, transit shelters must provide a 30-inch by 48-inch minimum clear space entirely within the shelter. Not surprisingly, the 30 by 48-inch requirement is the standard size of a wheelchair footprint. It needs to be entirely within the shelter. Where seating is provided within the transit shelter, the clear space must be either located at one end of the seat or so as not to overlap the area within the 18 inches of the front edge of the seat. So what that means is you either put it so that a person in a wheelchair can park so that they're oriented the same direction as all the other pedestrians waiting in the transit shelter, which is usually at the end of the row of seats, or you have it so that they can park in front of the people sitting in the seat, but not making people have to move because you've gotten them too close to the seat. That's what that 18 inches is for, to give person who's already sitting in the shelter at the seat enough room for them to still stay seated, and a person in a wheelchair can park next to them, usually parallel to them, and not block their ability to sit in the space. So that's where that 18 inches comes from. Now, on-street parking. On-street parking is covered in R310. 310.2, parallel on-street parking spaces. 310.3 deals with perpendicular parking spaces. 310.4 deals with the angled parking spaces. 310.5 is common requirements for perpendicular and angled parking spaces. 310.6 deals with the parking meters and parking pay stations. So if we go into this, in the proposed rule, we hadn't specified the actual dimensions of the parking space. We had just indicated that it would be a parking space that has, that meets the local requirements. But in the final rule, we have actually specified the size of the minimum size of the parking space, a parallel parking space. That parallel parking space be 24 feet long minimum by 13 feet wide minimum. Parallel on-street parking spaces cannot encroach on the traveled way. Now, there is an exception here. It says where parallel on-street parking spaces are altered, but the adjacent pedestrian circulation path is not, an accessible parallel on-street parking spaces provided may have the same dimensions as the adjacent parallel on-street parking spaces if they're provided nearest the crosswalk at the end of the block face or nearest a mid-block crosswalk, and a curb ramp or blended transition is provided serving that crosswalk. So basically, it's so that a person can still get onto the sidewalk in that condition and don't necessarily have the additional width for the access side. So parallel on-street parking spaces, the second exception deals with in alterations where providing parallel on-street parking spaces. If you don't have the right-of-way width to provide at least 9 feet of sidewalk, essentially provided from the curb line to the right-of-way line, then you are allowed to provide the parallel on-street parking spaces with the same dimensions as the adjacent parallel on-street parking spaces, as long as they are provided either nearest the crosswalk at the end of the block face or nearest a mid-block crosswalk, so that you can access the curb ramp or blended transition that is serving that crosswalk. So similar exception to exception 1, just dealing with a different issue of right-of-way width. You have to have a pedestrian access route connecting to this parallel parking space. Parallel on-street parking spaces must connect to a pedestrian access route. Where curb ramps and blended transitions are used, they cannot reduce the required width or length of the parking spaces and must be located at either end of the parking space. Detectable warning surfaces are not required on curb ramps and blended transitions used exclusively to connect accessible on-street parallel parking spaces to the pedestrian access route. If it's used both as a way to get to the parking and a crossing, it does have to have detectable warning. But if it's only meeting the detectable warning, the detectable warning services are not required if it's only serving the parking space alone and nothing else. Where 2 or more accessible parallel on-street parking spaces are contiguous on a block face, each accessible parallel on-street parking space must have an independent connection to the pedestrian access route. So what that does is makes it so that you don't have to depend on the way your the person that parked in front of you or behind you park their vehicle to affect whether you can get on to the pedestrian path or not, because you've got an independent connection from the one that's next to you. Okay, pedestrian accessible route connection, there's an exception to this connection requirement. In alterations, of course, where parallel on-street parking spaces are provided in accordance with exception 1 or 2 to R310.2.1, if you remember those exceptions I just talked about, the parallel on-street parking space must be connected to the curb ramp or blended transition serving the crosswalk by a pedestrian circulation path complying with R302.6. Okay. Now, if we move on to and this graphic kind of shows you what we're talking about. We go on to the next thing. Now, there has to be clear space adjacent to the parking space. This becomes very important for for a lot of reasons. The center 50% of the length of the sidewalk or other surface adjacent to an accessible parallel parking space must be free of obstructions, including parking identification signs, parking pay meters and parking pay stations, any kind of street furniture, and also of any landscaping that may be provided, and must comply with R302.6 surface requirements. So this graphic shows you very well. It's basically the center 50% has to be clear of anything, and it basically needs to be a surface complying with 302.6, which means stable, firm, and slip resistant. And basically what that's giving you is the ability to deploy your ramp or your lift onto the sidewalk from your parking space. And so you're not trying to drop your lift or your ramp into a planting bed or into the street tree or into your parking pay meter, all those kind of things. So it needs to be free of any furniture or landscaping. The middle 50% of your parking space length. Now, parallel on-street parking space identification. Parallel on-street parking spaces must be identified by signs displaying the international symbol of accessibility, complying with R411. Signs must be 60 inches minimum above the ground surface measured to the bottom of the sign. So whatever ground you've mounted the pole on, 60 inches up to the bottom of the sign. Now, with perpendicular parking spaces, it's a little different requirement. Perpendicular on-street parking spaces must have adjacent access aisles that are 96 inches wide minimum and extend the full length of the parking space. One access aisle is permitted to serve two parking spaces where front and rear entry parking are both permitted. So if you can back your van in, it's okay to share the access aisle. Where an access aisle serving only one parking space and parking is restricted to either front entry or rear entry orientation, the access aisle must be located on the passenger side of the vehicle. And that's because 99.9% of lift or ramp vehicles are the ramp or lift is on the passenger side. So if you are restricting whether it's rear entry or front entry and not allowing one or the other, then the access aisles cannot be shared and it has to be on the passenger side of the vehicle. The width of an angled parking space must be 132 inches. Okay, this is angled parking spaces. Each angled on-street parking space must have an adjacent access aisle 60 inches wide minimum, extending the full length of the parking space on the passenger side. Now, this is a change from the proposed rule, because the proposed rule, angled parking and perpendicular parking were similar in the requirement for the size. And what we've done here is with angled parking, we've given you a little more wiggle room inside the actual parking space for getting your vehicle placed in such a way that you can either get out of the passenger side or the driver's side, depending on what type of vehicle you have and whether you're a driver or a passenger. So that's the reason for this provision. And with angled parking, you also cannot share the access aisle, because in the angled parking, it is generally on-street angled parking generally does not allow rear entry. Thus, the access aisle is 60 inches wide minimum and extends the full length of the parking space and must be on the passenger side. So for each of the angled on-street accessible parking space. Perpendicular and angled parking spaces, so these requirements go to both of those. The access aisle surface must be marked to discourage parking in the access aisle. Access aisles must be located at the same level as the parking space they serve and cannot encroach on the traveled way. Access aisles must connect to pedestrian access routes. Where curb ramps and blended transitions are used, they cannot reduce the required width or length of the access aisle and parking space, same as parallel parking spaces. And again, detectable warning surfaces are not required on a curb ramp or blended transition used exclusively to connect on-street parking access aisles to the pedestrian access route. Again, but it's exclusively that's the only purpose of the curb ramp or blended transition. Now, again, same as the parallel parking space, perpendicular and angled parking spaces must have identification, and they must be identified by sign displaying the international symbol of accessibility, complying with R411, which I'll talk about in module 4. The signs must be located at the head of the parking space and must be 60 inches minimum above the ground surface measured to the bottom of the sign. Parking meters and parking pay stations that serve accessible parking spaces must provide operable parts complying with R403. Now, this is basically, it's requiring that if you have a parking meter or parking pay station, that has to meet the reach range requirements and be operable in the way it require operable parts to be operable with one hand and not require tight pinching or twisting of the wrist. A clear space must be located so that the displays and information on parking meters and pay stations are visible from a point located 40 inches maximum above the center of the clear space in front of the parking meter or parking pay station. So if I can explain that to you just a little bit, is you want to put a 30 by 48 inch clear space next to the pay station so that a person in a wheelchair can pay their parking bill, okay, or their parking fees, and at a height of 40 inches, which is typical eye height, or about the typical eye height. In this, if you take that from the center of the part of the clear space, that you can read the display, so that you know what you need to do to get what you need out of the parking meter. So that's the requirement, is 40 inches from the center line or the center point of the 30 by 48 inch space, clear space. Now, passenger loading zones. Passenger loading zones, like everything else pretty much in this rule, not required, but if they're provided. The vehicle pull-up space size is 96 inches wide by 20 feet long minimum. The access aisle size is 60 inches wide minimum, extending the full length of the pull-up space and at the same level as the pull-up space, so that it's not up on the curb, it's at the same level as the actual pull-up space. The surface must comply with 302.6, stable, firm, and slip resistant. Connect to pedestrian access route. Okay, you've got a connection requirement here again. And the access aisle is marked to discourage parking in it. One thing I do want to mention, which I'm not sure I did mention on parallel parking spaces, is that you do not mark the access aisle, because that gives you the ability to pull in close to the curb or pull away from the curb. But in all the other situations where I've said access aisles have to be marked to discourage parking in them, I didn't say that in parallel parking, and we did that so that you could be able to park close to the curb. Okay, so let's continue about passenger loading zones. Passenger loading zones, there has to be a clearance adjacent to it, similar to what you do with the parking space. It's a similar requirement, so you can deploy the lift or the ramp and be able to deploy directly onto the sidewalk. And that center 50% of the length of the sidewalk has to be clear, must be free of obstructions. That includes all the street furniture I mentioned in the earlier slide, and any landscaping or that nature. And the surface must be stable, firm, and slip resistant and comply with R302.6. So let's go on here. And passenger loading zones, again, must be connected to the pedestrian access route. The same way parking spaces required to be connected. Access aisles must connect to a pedestrian access route. There is an exception for alterations. Where curb ramps and blender transitions are used, they cannot reduce the required width or length of the access aisle. Detectable warning surfaces are not required on curb ramps and blender transitions used exclusively to connect access aisles to pedestrian access routes in a passenger loading zone. So same condition, it's only when it's exclusively used for that can you skip the detectable warning. This concludes the third training module of the finalized public right-of-way accessibility guidelines. For questions on this module, you can email row@access-board.gov. Join us next for Chapter 4 of the public right-of-way accessibility guidelines final rule training module.